All right, welcome back everyone. This video will deal with objects, or rather the work done on objects, purely by the gravitational force. Okay, and for starters, in chapter 7, in this example specifically, I'm purely dealing with objects moving straight up. In other words, only the vertically. I'm not necessarily worrying about objects moving as a projectile, right, in both x and y for right now. We'll leave that for next chapter, in chapter 8. So, to start off, let's see what the work is for an object starting at some height on the ground, if you will, and then it's being projected up with some initial speed to some maximum height. Okay, we'll call that capital H. All right. So, while it's in the air, right, say if you throw a ball, once it leaves your hand, the only force on it is gravity, ignoring the little bit of air resistance, of course. So, like I've implied, as it's moving up means its displacement is pointing upwards. I'm going to write that as the y vector, right? You can actually put that as dy, you can put that as r vector, you can even write that as h if you will, but for right now I'm putting it as y because that's the positive y direction. The gravitational force on that object the entire time it's in the air is downwards. All right? So these are in opposite directions. Would you think the work done by gravity is positive or negative in this case? Well, let's find out for sure. So in previous videos, we've defined work as the integral of the force dotted with some displacement. And that's the same thing here. So our gravitational force dotted with our displacement dy, right? So this is the general form for work, right? This is the form you should always use because this will always apply. Just simply F dot D, or rather F times D, will not always apply, right? Sometimes you'll have a variable force or your angle will change. In this case, the gravitational force magnitude doesn't change. The angle is not changing, but the height is changing. Okay? So we want to find the work done across all of those differential heights. So let's evaluate this. Let's write each of these terms here in unit vector notation. So let's keep the integral sign, right? And this is from, point A to point B. So the magnitude of Fg is mg, and its direction, as we've specified, is negative y hat. And yes, you can use negative j hat also if you feel more comfortable using that. That's fine. The dot is still there. The dot product is still there. We have not evaluated the magnitude of that yet. The magnitude of dy right here is, well, dy, and its direction is positive y hat. Okay? So again, we have magnitude and direction. This is unit vector notation. And so now, let's see. Evaluating the magnitude of this dot product, we're doing the integral last, means we have the magnitude of both vectors. So mg times dy times cosine of the angle in between. Well, what's the angle in between negative y hat and y hat? Well, that's 180. And so that equals negative 1. And so the work done in this case is actually negative mg in evaluating the integral of dy, right? We have that. So going from A to B, right? Some height A to some height B. And that really boils down to simply being negative mg capital H. And that's our work. All right? That's the work done by gravity. It turns out it's a negative value. But it's only a negative value as the object is moving up, right? Because the force and the displacement vectors are in opposite directions. Thus, we get a negative work value. Okay? That's very important here. It's a subtle point, but it's an important point. Okay? More generally, this can be turned into, it's the negative change in potential energy. Okay, so that's what work is also known as. In previous videos, we saw work as, I guess I'll write it there, as positive, the change in kinetic energy. Well, now, for a gravitational force, it turns out it's the negative change in potential energy. And this is the crux of Chapter 8. Right? This will come back and be very, very important in Chapter 8. Okay? But for right now, I'm just giving you a little bit of a heads up. Work is both of these things, negative delta U and a positive delta K. So what does this mean? What does this mean? It means that as this object, or as any object, is increasing in height, right? Increasing in height, moving against the force of gravity, the gravitational force specifically is doing negative work. Okay? In other words, the potential energy is becoming more and more negative. Right? Let's see what happens when it starts at the top here and then falls down. All right, so let's do that down here. So it starts at some height h, and now it's going down. I'm still going to have up as plus y. Okay? So as this object moves down, it's actually initial speed of 0, right? It goes up to a rest. So on its way down, well, the force of gravity is still pointing down. Whoops. Don't switch the color schemes. Force of gravity in blue, downwards. Its displacement vector, well, it's moving down, so that points down now as well. Let's do there. All right, so this is now in the same direction. So let's evaluate the work really quick. Work, integral, force of gravity, dot dy, right? Again, from point A to point B. And now, since f and dy are in the same direction, we should get cosine of 0 instead of cosine 180. Right? So I'll leave the details to you if you want to show yourself and recreate it, but you should get a positive mgh. Okay? And so now the work done is a positive change, a positive delta U, when they're in the same direction. That's because the force of gravity is pulling that object in that direction, right? And doing maximum work on it, okay? It's changing its speed, if you will, right? It's increasing its speed specifically. Whereas up here, in this case, the force of gravity was acting to decrease the speed. Okay, that's the important part here. All right, so actually I should box this part. Right? That is very important. So for the gravitational force specifically, it's equal to, in magnitude, mgh, or mgy, right? Mass times gravity times some change in height. And whether it's plus or minus depends on if the object is moving up or moving down, right? In the direction of the force or opposite the direction of the force. All right, so thanks for watching.